Hey, this is Scott. Welcome back to my YouTube channel where I do a variety of different data science analytics videos. Today we're going to actually do a multivariate statistical analysis. This is going to be a short video on how to compute a multivariate t-statistic. So this data comes from Johnson and Wishern. And so we're going to get right straight to it. If you can see my screen, what I'm going to do here is I'm going to throw this means vector into x bar right here using R and the matrix function. So matrix, and then I have a column vector, 3 rows, so a 3 by 1 vector here that I create right here, and then boom, I hit Control Enter, and that's it. Now I'm going to construct a sample covariance matrix, and so that'll be a 3 by 3 using the matrix function along with the combine R function. Boom, that's done there. Control Enter, and then one more. I'm going to construct this contrast or coefficient matrix. It's going to be a 2 by 3. Where I'm going to contrast the different rows here, and then that's that. And then I'm going to replicate. I'm going to say that we had 40 individuals to construct this means replication. So that is in 40. Just to check things out, X bar, there it is, 46.1, 57.3 here in the lower panel. The covariance matrix right there, and then finally the contrast right there. Okay, so when I originally did this, I was in SAS IML. Just to show you, SAS IML is actually a lot more straightforward than R to do this type of thing. So if I was to calculate the t-square directly from SAS, what I'd be doing is I would take the n sample size, and then I would multiply it by C times X bar prime. So this would be prime transpose times the inverse of C times S times C prime, the transpose of that, times C times X bar. So that would be the simple math. In fact, I can show you what that would look like real quickly. This is the formula right here. We're calculating t squared right here, and this is that formula. All right. So if you want to do it real quick, I'm going to do it real quick, and then I'm going to do it ugly. So I'm sorry, ugly, and then I'm going to break it out into components so that you can see the components. But this is the way you do it. Directly, this is the scalar n times the transpose of C times X bar. So you'll note that this is not just a simple scalar multiplication like over here. It's actually used the what's that called? Is that an emperor? No, percentage sign, whatever. There's another name for it. But anyway, percentage sign, asterisk percentage sign times X bar. And then we do the same over here. But since we're taking the inverse, we use the R function solve. And then we have C solve for C times S times C prime, or the transpose of C in R. It's the same thing. And then times C times X bar. So if we do this and we figure that, then we get, I didn't mean to do that really. I meant to do t squared. And it's 90.49458. Okay, so if I break it out into components, what I can do is I just kind of did it where I would take these individual components, and again, so CX bar is just this thing right here, And again, I make a comment here that it's not just a scalar, and I should say it's not this, but that. Okay, and then let's do the inverse. So the inverse here, and I'm just taking that, and let's see what that is actually, whether it calculated. It did. And now I'm going to take the inverse of that thing with this solve function. And oops, ooh. And that's what I get there. And then the last part, this part over here, is just C times X bar and matrix multiplication, and I get that. And so the t squared is bringing all those three components together. These are the three chunks that I just took out, and multiply that out. And there it is. Verify that t squared is equal to t squared. And sure enough, down here they are. All right, so hopefully that was meaningful. And I hope you subscribe to my channel. Give me a thumbs up. I appreciate it.